You would have heard billion parameters, trillion parameters, while coming across various LLMs. So, what are parameters? They are the factors that an AI system learns from its training data and subsequently utilizes to make predictions. These parameters shape the AI's understanding of language, influencing how it processes input and formulates output. Each parameter is like a piece in a grand jigsaw puzzle, with the complete picture being a model's ability to generate human-like text. Mainly, two types of parameters are being used. First one is weights, and another one is biases. Let's understand them one by one. What are weights? Weights, also known as coefficients or parameters, are the strength or amplitude of the connections between neurons in different neural network layers. They determine how much influence the input will have on the output. What are biases? They allow the model to accurately fit the data by shifting the activation function's input horizontally. Biases typically initialized to small constant values, such as 0 or 0.01. Let's look at the example. Here, X represents input value, W represents the weight, whereas B represents bias. And the output value Z will be used for the activation function, which will determine the output of the neuron. Here we have visual representation of the same example. Currently, GPT-4 uses 1.8 trillion parameters, but that was not always the case. GPT-1 had 117 million parameters, GPT-2 had 1.5 billion parameters, GPT-3 having 170 billion parameters. Currently, Grok 3 has 2.7 trillion parameters. Does more parameters always mean better performance? Not necessarily. Having large number of parameter has its own downside, like overfitting and computational cost. Overfitting happens when large amounts of irrelevant information results in accurate predictions for training data, but not for new data. So when it comes to new data, it won't generate optimal results. Also, it leads to increased computational costs during training and inference due to need for more memory, processing power, and longer training times. So what else affects the output quality other than parameters? Turns out the quality of data also matters that we have fed during the training, along with type of task, like coding, solving complex math problem, generating creative output, etc. That's it for this video. Thank you.